Friends, how are you all? So, students, we have started atoms and molecules as a new chapter, and where we have discussed about in my last lecture, we have discussed about the Dalton's atomic theory, right? Where we have discussed about the various postulates of the Dalton, which he have concluded. He had given the conclusions regarding the atom, its existence, it is found in the combined state, how in which form it is combined with the other atoms of the same or the different elements to form the compounds, etc. So, and similarly, we have discussed the various drawbacks or the limitations of the Dalton's atomic theory. So, students, now this is the time to know the few basic definitions of the chapter before starting with the ionic compounds, before starting with the how to calculate the molecular masses of the mole concept. So let us start with the few definitions which are required by us to know, to learn about. First of all, what is an atom? We were discussing about the atom from the start of the chapter. Now, exactly what is an atom? Atom is the smallest part of an element which may or may not have an independent existence, right? For example, if it is found in the solid state, it may have the free existence, or it is found in the gaseous state, it may or may not have an independent existence. It will be always found in the combined state, right? But it is the smallest part which always take part in a chemical reaction. How we can come to know it about? Because whenever we see whether the equation is balanced or no, we always used to calculate the number of atoms of each element in the reactant sites to be equal with the number of atoms of each element in the product side, right? So that's why we used to say that it is atom which always take part in the chemical reaction, not the molecule, right? Now we have discussed about the atoms. Now students, about the size. It is so small in size that we cannot see it even with the microscope. Doesn't possible to see with the naked eye, but even cannot be seen through the compound microscopes and such, right? Because it is so small, it is smaller even than 10 raised to minus 10 meters, right? Now students, about the existence, about the state, as I have told you people, it is found either in the free state like the sodium, magnesium, aluminum, or in the combined state like the oxygen, hydrogen, chlorine, bromine, iodine, etc., etc. Now, we are just going to discuss about the symbols. What is a symbol? Symbol is the shorthand form of element, right? Either in a simple one alphabet, or the first alphabet of the letter of the name of the element along with the other alphabet, right? So how it will be, for example, I have taken of all C, right? Shorthand forms of the full names of the element, like C is for the carbon. Only C is there because it is at the start of the periodic table, right? That's why. And then CO is the symbol for the cobalt. First alphabet C of the cobalt is taken, and then one more alphabet O is taken just to write it. Similarly, I have written copper. It is taken from the Latin name cuprum, right? So Cu is a symbol. Similarly, chlorine, the first alphabet C, and then the L will be taken along with C, right? So this is simply the shortened form, because just to write the formulas, just to write the equations, or to balance the equation, we cannot write the full name of the element. That time we require to write the symbols to make our things easier to understand, right? Now students, next we are just going to discuss a few definitions like the relative atomic mass, right? As such, we have discussed earlier, atom is very small in size. If it will be very small in size, so automatically the mass of an individual atom, it might be very simple, very small, negligible, right? Maybe 10 raised to a minus 30, 10 raised to a minus 24, and so on. So which will be really very difficult to understand about as the atomic mass, right? So that's why scientists, they have tried their level best to make a reference point for the just to calculate, to compare the mass of an atom of any element. So they have earlier tried for the hydrogen, oxygen, but their observations, they were not being successful while taking hydrogen as a reference point or the oxygen as. And finally, they have uniformly concluded that carbon, one of the isotope of the carbon, that is carbon 12, if it will be taken as a reference point, then to understand about the atomic mass, it will be very easy of any of the element, right? So let us discuss about what is this. So IUPAC recommended C12, that is carbon 12 isotope of the carbon as reference. So the atomic mass of an element is the relative mass. It will be the relative mass, not the exact mass which is compared with. So that's for relative mass of its atom as compared with the carbon 12 isotope of carbon taken as 12 units. You know, isotope of the carbon 12. So carbon is found in the two isotopes, that is C612 as well as C614. So here normal carbon is taken for the reference, not the isotopic carbon, right? Now, or it can also be defined in a other simple way, that is number of times the given atom of any element, maybe sodium, maybe magnesium, maybe any other element, so is heavier than 1/12 of the mass of carbon 12. Example, magnesium, mass unit of the magnesium, mass number, it is 24, right? 24 into 1/12, it is coming 2, right? So that's why magnesium is 2 times heavier than the mass of the carbon, right? Carbon 12, which is taken as standard unit. Now, what is atomic mass unit? AMU, written in the simple form, defines as 1/12 of the mass of an atom of carbon 12 isotope, right? This is also called AMU, written with the unit U, right? So now, when some of the isotopes of the some elements are known to us, for example, chlorine. Chlorine is having the two isotopes. First will be mass number 35 and second will be mass number 37. Now, how to define the atomic mass of chlorine? In such cases, we assume that how many atoms which are constituting the total element chlorine, three part. So only 1/4 will be of the 37 mass number and 3 parts they will be of the mass number 35, right? So now calculating the average of it, that is 3 parts of 35. Let it be 100 atoms which are constituting chlorine. Out of those, 3 are 3 parts, right? That will be of the 35 and 1 will be of 37. And divided by 3 plus 1, it is coming 35.5 units. This is for the average mass of chlorine. How it will be defined? Atomic mass of an element is average relative mass of its atom as compared with the mass of 1/12 isotope of carbon 12. So same definition is there. Hardly the term average we have used, because in such cases we used to calculate the average of the atom, right? Now students, in my next lecture we are just going to discuss about the few very important elements, their mass number. For example, hydrogen. Normal hydrogen is having mass 1. Similarly, second is the helium, mass 4. Similarly, lithium, mass 7 is there. Similarly, beryllium is there with the 9. So boron with the 10. So carbon with the 12. So in the same way, first 20 elements we are just going to describe in detail about the total symbol, means what is the atomic number, what is the mass number, number of proton, electrons, neutrons of the particular atoms of the element, right? So we are just going to make ourselves confirm before understanding about the molecule, right? Thank you.